Good evening, everyone. Today I am discussing about the calculation of the critical frequency and the roll-off rate of the filters. So, suppose that we are designing single pole low pass filters. It means single pole low pass filter. Means this is the circuit diagram of this low pass filter. We are using this unity gain feedback and connecting with the one single. This is the frequency selective network. This is called RC network. Okay, so in this case, suppose that we want to find the roll-off rate and critical frequency. So how can determine this critical frequency and roll-off rate? Suppose that single pole is given. It means this is called first order. This is called first. This is a single pole. It means this is called first order. And suppose that FC is called the critical frequency. So the determine the value of this critical frequency that can be decided by the value of R and C. It means each R of C set of the filter is called that decide the pole. It means that this is called single RC circuit. This means the single pole. Okay, so it means you want to calculate this roll-off factor. The greater value of this roll-off rate can be achieved the more pole. So it means higher value of this roll-off rate. It means that can achieve the more pole. Oh, okay. Suppose we are taking one example. So the number of poles determine the roll-off rate. It means maximum value of the roll-off rate can be determined with the help of the poles, number of poles. Okay, so we are taking one example. Okay, so a Butterworth response produce a minus 10 dB per decade. So we want to calculate this roll-off factor. Suppose that we have the one pole. In the one pole means first order. Okay, so it means the roll-off factor is the minus 20 dB per decade. Okay, so another thing. Suppose that we have a two pole. Two pole means two RC network. Okay, so the second order it means second order. This is filter as a roll-off minus 40 dB per decade. Okay. Okay. Next is suppose that we have the three poles. It means the third order. Okay, three RC network is connected. Okay, filter has a roll off of the minus 60 degrees. So we can represent it in terms of this now gain versus this now frequency. So cutoff frequency is given FC. So suppose that gain is as like the 0 dB, and then we are increasing this the cutoff frequency in terms of the in terms of this now higher value. So roll off factor will increases. So this is called this is so suppose that cutoff frequency this 10 time of the you are considering 10 time at 10 f, then the roll off factor this minus 60 dB per decade. So similarly, so we can calculate this roll off factor with respect to the poles. Okay. So suppose that you want to design this cascading manner of this filters. It means number of filters poles can be decide the cascading. Okay, it means number of filters poles can be increased by using the cascading. Okay, so in this uh, design to obtain the we are targeting the three poles, so the cascade of the two poles with one pole filters. Okay, so we are connecting two poles with the one pole filters. Okay, so we can say that the third order filters. So we are connecting three RC network. So this is this RC, and this RC network decides the orders. Okay, so this is the three RC networks. So that is called third order RC filter. This is called three poles low pass filter. This means three RC. This three RC means that is called third order filter. So we are connecting three cascading a single pole filter. So this is called third order low pass filter. So high pass filter response means we want to identify the actual response of the high pass filter. So suppose that high pass filter circuitry is given. This is network in the RC network applying the voltage Vi. Okay, so we want to find the actual response of this high pass filter. This means ideally we want to check this now response of this high pass filter, it means that is the stop the all frequencies up to this FL, and it means stop band lie between 0 to FL, and that passes the above frequencies this FL. It means passband lie between above the FL frequency. So this is the ideal response of the this high pass filters. Okay, high pass filter means that significantly attenuate or reject all frequencies below this value cutoff frequency, passes the above all frequency. This cutoff frequency, it means you are it means that reject the below frequency, and then that passes the this above the cutoff frequency. So this is the meaning of this high pass filter. So we want to check the actual response of this this high pass filter. So suppose that this is given as like is the high pass filter response. It means the cutoff frequency lie between 0.01 fc to fc. It means behavior of this low pass filter. This means you want to check the at the point of the minus 3 dB cutoff. This is the response. This is minus 3 dB to 0. It means uh, suppose that in this case, F above the FC passband is rise abruptly above the FC. So this passband lie between the above the cutoff frequencies. Okay. So roll off factor lie in between the minus 20 dB per decade, and minimum attenuation lie between 0 to minus 3 dB of the at this is called cutoff frequencies. So this is called the actual response of the low high pass filters.